increasing, nice. I write this here. Increasing intervals. Okay. So, what is the function increase? So, what does that mean? Is it's saying the places that the function start to increase in value. So what happened is as x get bigger and bigger, the function start going, the y values start getting higher, bigger and bigger. So that's what it means by increase. X increase, y increases too. Now the function is decreasing in an interval with x increasing and y is decreasing. So I'll show you. It's probably better in the picture. So in this interval, so I'm going all the way from infinity, negative infinity, to infinity. So from negative infinity, right here, this function is doing what? It's going from negative infinity, right here was negative. It goes all the way down to. So it was negative. It was what, up all the way. So from negative infinity here, you see the y value would be based off of this would be what? Y values go all the way up. So from negative infinity, the y value is based all the way up, and even at -3 here, there's a y value all the way out here. At -2, the y value is right here. At 1, the y value goes down here. So what is this function doing? Is it in this interval? Is it increasing or decreasing from negative infinity to -1? We're gonna cover increasing and decreasing in both, kind of like the same way. So let's take the intervals. From negative infinity, I stop at 1, at -1. Is this function increasing or decreasing? So from like you can see -3, I was here high. Maybe that was, let's say that was 9 or something. And then at 2, I go all the way down to, let's say this is 2. At 1, I go all the way down to 0. Is the function increasing or decreasing in this interval? And if it's decreasing, we're gonna put it. And then we're gonna consider the next interval. Let's see. Let me see what y'all have for me. Nope. Emerson. What's up? Nicholas. That's what's up, Nicholas. Decreasing. Okay, Elizabeth, that's what's up. Decreasing. That's right. So let's see who else is here. Oops, I lied. Luke, Ashley, Timothy. Let me know if you have any trouble. Okay, decreasing. So what it's saying is, as I'm putting higher and higher value of x in this interval, as I'm putting higher and higher value of x, because you remember, negative infinity is less than -3. -3 is less than -2. So as I'm going to the right, so what's happening? The function is going down. It was right here. It goes right here. It goes right here. So in this interval, this is decreasing. Decreasing. So it's decreasing in this interval. Now let's consider the second interval. So from here, from -1 to, and the intervals that we're going to consider is all like intervals where the functions start changing direction. It was doing something, it started doing something else. So it's easy, you see them. So here it was going down, now it started doing something else because it doesn't go in the same direction. It was going this direction, and all of a sudden it flipped to something else. Same thing here, was going in this direction, flips to something else. Same thing here too. So in this interval, which is the interval -1, 0, and that will cover both things, increase and decrease. -1, 0. What is the function doing? What is the function doing from -1 to 0? Is it going up or is it going down? -1 to 0. So let's see. So let's consider a value that's here. Let's say 1.5, negative 0.5 function is here. As I'm going increasing in x, is the function going up or down in this interval? So as I'm going to the right, is it going up? You see the bars? Are these bars going higher or they start getting smaller? In this case, these bars started getting smaller. As I'm going to the right here, do they start getting higher, bigger, or smaller? So that will tell you if it's increasing or decreasing. And the same thing with this interval too. Are these bars getting shorter or longer? And that's a kind of cool way to identify what's going on. And this interval from negative infinity to zero, are the bars getting bigger or smaller? So in this interval, are we increasing or decreasing? Let's see. Appreciate it, Barbie. Yeah, it's getting bigger. Does that mean the function is increasing or decreasing from left to right? Yeah, it's getting bigger from left to right. Does that mean we're decreasing or increasing? All right, let's see. You guys are quiet on Instagram. So yeah, Sarah, that's right. It's increasing. Bell, I don't want to mess up your name. Bell Rana, it's increasing. Yeah, that's what's happening. So the bars, because these bars are getting bigger, it's increasing. It's increasing in this interval. Decrease here and an increase here. Increasing. Now, from the interval of from 0 to 1, and that's where the function changes directions again. From 0 to 1, as you can see, the bars, the black ones, are getting shorter. Does that mean the function is increasing or decreasing? So, see, the black ones are getting, these bars are getting shorter. Does that mean the function is increasing or decreasing? In this case, increase or decrease? And the interval 0 to 1, 0 to 1. Are the values getting a little bit shorter, smaller, or they're getting higher? So, increase or decrease in that interval? Increase, that's right. Yeah, so it's increasing. Ricky Rodriguez, on Instagram, welcome. Okay, Anna Ruval, why do you say decrease? It's getting higher. Yeah, it's increasing. It's decreasing. It goes lower in value. So what we're looking at is the y values. From here, say the point here, at 0, the function is at 1. At 0.5, it's right here. At 1, it dropped all the way down to 0. So it went from 1 to 0. So what happened? It went from a value of, a y value of 1 to a y value of 0. That means it's decreasing in this interval. Decreasing. Now, all right, so that's last interval. Last interval. So we see out here at 1, it's at 0. So we start moving all the way out here. So is the function increasing or decreasing? At 1, I was at 0. At 2, I'm all the way to a value of 2. At 3, let's say we call this a 9 or something. So was this function increasing or decreasing? Increasing, decreasing, increasing. Thanks. All right, cool. So in this case, it's increasing. Increasing. And this interval. The interval 0 to infinity. The function is going up in values. Usually, I give you a trick. So if if you have a function that doesn't, if the function doesn't have any asymptote, like it continues, so you probably gonna have an alternate. You're gonna have to alternate between increasing and decreasing. So what I mean by that, this first interval is decreasing, this is increasing, decreasing, increasing. You could have some constant G, but if the function changed, that means it's gonna go from increasing to decreasing. Now, that's if it's if it's a continuous function. If it's not, you may have stuff that'll change. So decreasing, increasing, decreasing, increasing, and I think this is it for this one. I think we can move on to let's move on to something else, and then maybe another time we'll come back and do some more stuff on this. There's no constant. Is this an even or odd function? So who can tell me if it's an even or odd function? Now let's move on to something else. All right, so we're gonna do imaginary numbers. All right, let's do some imaginary numbers, and then we're probably gonna wrap it up. All right, that's probably not a good title for this topic. So now here's what happened when there's a set of values that we call the real numbers. The real numbers are numbers like 15, 3 over 7, 146, -5, 0. These are the real numbers. But there's certain equations when we solving them. Let's say that you're solving a quadratic equation, you come to something that's x is equal to square root of 16. Now, square root of -16. Now, what in this case, there's not a possible solution for this in real numbers, but there is something that they call imaginary numbers. So what they do, the folks who are really, really good at math, what they did is they replaced this negative here by I squared. Now, there are two ways that you can see this in school. You can see I squared is equal to -1, or I is equal to square root of -1. These are both the same thing. So if you square this thing, right here, you square this thing, I squared is equal to -1. I think I learned it the second way. I squared is equal to -1. So now what that allows us to do is, because this is square, you replace this by I squared. So what you would have is x is equal to square root of 16I squared, and then you can say plus I minus 4I. Now, that's what this allows us to do. This is where you get that introduced to. Now, we'll do some operation on imaginary numbers. So, remember, imaginary numbers are, this is what you need to remember. Either you remember I is equal to square root of -1, you can remember it that way, or you can remember I squared is equal to -1. Those are the same thing, pretty much. So now from this, let's do some cool stuff. And the first thing that we're going to do is multiply a bunch of I together. We're going to see what happens. So let's multiply I squared times another I. What do we get if we multiply I squared by another I? Let's see. I mean, I know we get I to the third, but what's another way to write that? Why is this not connecting with that? I don't know why is that the percent. So we get I to the third. You get 1. Okay, somebody say you get 1. All right, cool. So when you multiply, and I'm gonna show you something cool, and you're probably gonna hate it. So when you multiply I by another I, you get I to the third, right? I to the third. Or you could say I squared. I know I squared is -1. So that would be -1 multiplied by an I, which would be or negative I. Negative I. Now let's say what happened if we multiply I squared by another I squared. That would mean what? A -1 times another -1. What's -1 times -1? 1. So now we know from the top of our head, I to the second power. Let's see what we know. Now, I to the fourth is 1, based on this little calculation that I just did. I to the third is what? Is -I. I squared is -1. What's I to the first? I to the first is I, right? What's I to the 0? What's I to the 0? You can tell me what I to the 0. I'm gonna give you a second to think about this. And you're gonna see something cool that you probably see in your class when you do I to the 0. I to the 0 is 1. That's why. Man, that's what's up. 1, 1. I to the 0, 1. No. Shama. It's not 0. Anything to 0 power is 1. What's a million to the 0? What's 5 million to the 0? 1. What's 600,000 to the 0? 1. -1 to the 0, as long as you put parentheses. So I to the 0, 1. So I to the 0 is 1. Now let's go and do I to the 5th. So I to the 5th would be, and we're gonna end with this, and then it's gonna help you a lot. So I to the 5th is, and if you take the complex numbers, you probably see what I'm about to say, is I to the 4th times another I. We could say I to the 4th times another I, or I to the 2nd times I to the 3rd, or any how you want to. What's I to the 4th? I to the 4th goes all the way to 1. So that means we have 1 multiplied by an I, right? I is I. That gives us I. So I to the 5th is I. Let me write these in blank so you can see what's starting to happen. I to the 5th is I. Write this in black too. As 1. So now, what's I to the 6th? I to the 6th is I to the 5th times another I. Or you could say I to the 3rd times I to the 3rd. Or you could say I to the 4th times I to the 2nd. So I to the 6th, and when we get to 7, we're going to stop, as I to the 3rd times I to the 3rd. 3 plus 3 is 6. What's I to the 3rd? -I. What's I to the 3rd? -I. So what does that give you? A negative times a negative is a positive. I times I is I squared, all right? So we have a positive. This becomes a positive. I squared. What's I squared? -1. Now, do you see what kind of numbers we're getting? It's like 4 of them. So we're getting the 1, the I, the -1, and then the negative I. Those are the same one that we keep getting. And it really doesn't matter. I to the 6 is -1. It really doesn't matter I to whatever number that you have, you're still going to have those 4 different volumes. 1, -1, I, -I. So now, let me show you something cool that we can do. So, now, who can tell me what's I to the 40? Now, let's say you go in the exam. They say, hey, Peter, Mark, Andre, Adriana, what's I to the 400? What's I to the 400? So, who can tell me what this is? And then I'm going to give you the answer, how to find it real quick. And don't try to do this. Oh, I have 5 minutes left on this. A few seconds left on this. I to the 400. One. That's what's up. Somebody say one. Maddie, did you just say this one, or was that fun different answer? One. Yeah. Okay. Now, that person who find one, I'm sure she didn't, or he or she didn't go and do I squared times I squared times I. She didn't do that, because I'm pretty sure it wouldn't be, she wouldn't find the answer that fast. So it turns out, like I said, there's only 4 possible values: 1, -1, I, -I. So the way you know which value is going to set to is what you do is you take the exponent, you divide it by 4, and whatever the remainder is, not what the quotient is, what the remainder is what you're gonna find, is what the answer will give you. So 4 divided, so in this case, no. So whatever the remainder is, you match that to I of that remainder. So when you divide it by 4, the possible remainders are 0, 1, 2, 3. So let's say 7. 7 divided by 4, there's only 1 4 in 7, and the remainder is 3. 6 divided by, so you match that to I3. And that would give you, so I to the 7 is equal to I to the 3rd, which is equal to -I. You just match it to whatever the remainder is. What's I to the 400? That's what she's saying. I to the 400 is equal to I to the remainder. When you divide 400 by 0, the remainder is 0. By 4, the remainder is 0. So I to the 400 is equal to I to the 0, which is equal to 1. There's only 4 possible remainder when you divide stuff by 4. 0, if it's divisible by 4. 1, if it's something like 5, because you say 5 divided by 4. There's only 1 4 in it, and the remainder is 1. There's 2, 3. So those are only 4 possible remainder. So now, this one, in this case, the remainder was 0. We match it to I to the 0, which is 1. If the remainder is 1, we match it, add to I to the 1st, which is I. If the remainder is 2, we match it to I to the 2nd, which is -1. If the remainder is 3, we match it to I to the 3rd, which is -I. I to the 7 is the same thing as saying as I to the 3rd, because when you divide 7 by 4, the remainder is 3, and you match it to -I. So what's I to the 403? All right, who can tell me this? Not that big of a number. How about 43? What's I to the 43? Who you tell me what I to the 43 is? And then we're gonna probably end. Ooh, Facebook is gone. TikTok, download, share on IDTV. Lord. Okay. You guys on TikTok, you're the only one here. All right, so -I, yeah, that's what's up. So yes, so -I. So that's how you do it. Remainder is 3. So that you match it to I to the 3rd. I to the 3rd, -3. So bottom line is, don't do these by hands. There's an easier to do them, and that's how you would do it. So your host, Romel, with the Jax Tutor. If you need our help, you can go on our site, and that's it. That's it for now, and I'll catch you guys another time. Thanks. Bye.